So because we're changing bound and all of these, or most of these, we're looking at definite integrals. Definite integral means we have a lower number and an upper number, not a variable. So that means, are we going to add c at the very end after we integrate? No, because if it's got definite integral, we're going to add c and subtract c at the end. They're going to cancel out. So let's write on here, no c, since it's bounded. And bounded means we have an upper and lower bound. And I know normally I would have you guys read all this, but I'm going to go ahead and explain that process off on the side. So, as if we are just doing our normal u substitution, what is going to be in place of u? So we have x squared plus 1. And when I derive, we get du is equal to 2x dx. And then we would have to go ahead and compare from the original and make sure I have all the pieces. I see an x, I see a dx, so we're good. How am I going to move the 2 over? Divide. So now when I rewrite this, all of this rewritten is going to be the following. The integration of, do not write the upper and lower bound today, or for now. So we have u cubed du. Now in place of the u, we're going to actually plug something in. What they gave us was the upper bound is 1 and lower bound is 0. But when I plug it into our u is equal to, and I plug in x equals 1, what would give us our new u? 1 squared plus 1? 2. And what if I plug in the 0? U is equal to 1. So since I'm changing my bounds, you don't have to plug back in x squared plus 1 at the very end. So 1 and 2. So now let's go ahead and derive. Did y'all realize I forgot to put something at the beginning? The 1/2. So let's go ahead and integrate. Leave the 1/2. Give me a bracket. What is one more of the 3? So 1 over 4, u to the power of 4. Am I going to add plus c? No, because it is bounded. And then I'm going to put in, my upper bound is 2, lower is 1. At this point, all we have to do is just simply plug things in. But to make our life easy, let's bring the 1/4 to the outside. So if I take half times 1/4, that is 1 over 8. And I'm just simplifying at this point and not plugging in yet. So now let's plug in our numbers. 2 is going to go in place of the u. So let's leave 1 over 8. Bracket again. So u is going to be 2 to the power of 4. And then when I plug in the lower bound, what sign do I need? Minus 1 to the power of 4. Let's further simplify. We get 1 over 8. 16 minus 1. What is 16 minus 1? 15 over 8. And that is our final answer. And again, we did not have to plug the u back in terms of x because we changed our bounds. So the only new information today is this right here, changing our upper and lower bound. All right? So let's go on to our next one on the bottom. What is the first thing that I'm going to do because I do not like that fraction? Bring it to the top. So we have the integral from 1 to 5 of the x times 2x minus 1. And because we're bringing it to the top, I need negative 1/2 dx. So we are going to let u equal what? So let me go ahead and bracket this off. So we have u is equal to 2x minus 1, which is going to give us du is 2 dx. So let's compare. I have dx. I don't have the 2, so let's move that over by dividing. And then I have a question. We don't have an x. What was that called from yesterday? That other kind of Cocoa. And it was substitution. So what I need to do is take what the u was equal to and solve for x, because we have nothing on the x after deriving. So we know our x is equal to u plus 1 over 2. But I want that as a factor form, so 1 over 2, x plus 1. So let's put in what we know so far. And while we're at it, let's go ahead and put in our u substitution. If x is equal to 5, and when x is equal to 1, and I plug it into our u value, what is our new u? So u is equal to 9. What about when x equals 1? It's also equal to 1. So let's rewrite. Here's my integral from 1 to 9. And I'm going to take a few things out right now. I have this half that I'm going to take out. But do you see that other half that I can't take out while I'm at it? You don't have to, but I want to. So I have the following. We have u plus 1 and u to the power of negative 1/2 du. Any questions on where I'm getting the substitution from? Half du right here, and then half u plus 1 right here, and u to the negative 1 is by the u substitution. Okay? So let's go ahead and simplify certain things. Half and half is going to give me 1 over 4. Integration from 1 to 9. We are going to distribute. Now keep in mind, u to the power of 1 is technically 2 over 2. So when I do go ahead and simplify or distribute, we get u to the power of 1/2 plus u to the negative 1/2. And do I need my plus c here? Oh, I didn't even do the integration yet. But we won't need our c because it's bounded in the end. So let's go ahead and integrate at this point because all I did was rewrite. So leave the 1/4. Open up your bracket. And then I have, what is one more of this? 1 over 3 over 2. And u to the 3 over 2. What is one more of negative 1/2? 1/2. U to the 1/2. Close it. 9 and 1. Now after this, it's going to be tedious. So let's see how we can actually solve for this. And we'll take it step by step. Too many fractions, right? Too many? So the first thing we're going to do is plug in the 9. So leave the 1/4 as it is right here. So let's plug in the 9. We have 9 to the 3/2 over 3/2 plus 9 to the 1/2 over 1/2. And when I put in the bottom bound, I need to subtract. And I'm going to put in parentheses. We have 1 to the 3/2 over 3/2 plus 1 to the 1/2 over 3/2. All right, so here's what I want at this point. Leave the 1/4 as it is. Let's rewrite 3 over 2 in my denominator as 2 over 3. And let's do some side notes. If I have 9 to the 3/2, let's see what that means. And make sure you're listening because this is going back to like the simple math. What is square root of 9? What is 3 to the power of 3? 27. So we're really in the end multiplying this by 27. And then I have plus. So let's rewrite the 1/2 as 2. And let's write off to the side 9 to the 1/2. What is square root of 9? 3. So let's write that inside the parentheses. And then I know this guy right here is going to be minus 2/3. No matter what I do to the 1, is that going to change? 1 is not going to change. So you can write times 1 if you want. Because it's understood, maybe you don't need it. The next one right here. We're looking at, we got minus, is that 3 over 2? Or 2 over 3? Where's 1/2 coming from? got that one. Got that one. If there's a mistake, let me know. Oh, 1/2, yes. So Ruby was saying I didn't write 1/2 over here. Ruby, that's a point for you. Let me write this down. Is that right, Sam? Yeah. I'm glad you can repeat things. So when I take the 1/2 in reciprocal, that's going to give us 2, right? Thank you. And that 1 is not going to matter. So let's go ahead and close our bracket. So let's further simplify and see if we can get to one single value. So let's leave the 1/4 as it is. Inside the parentheses, what would this give me? 18? Because 27 divided by 3 times 2, it's going to give me 18. Plus 6, and then minus 2/3, and then minus 2. And if I further simplify, we get 1/4. I'm going to go over here. 1/4. And the whole numbers alone is going to give us 22 minus 2/3. And that 22 we don't like because I need to make it a common denominator. So why not 66 over 3? And that's going to give me 1/4 times 64 over 3. And then our last thing, that's going to give us 16 over 3. That's 64 divided by 4. So it's almost like the calculus part is fine, but then doing the simple math could be kind of confusing because too many fractions. Okay? All right. So let's move on to example number 3, and let's try that with your neighbor real quick. Go. And it's multiple choice, so you don't have to solve it all the way. Talk to your neighbor. Once I get them regraded, since I gave y'all 3 days, give me 3 days. All right, let's check on the bound. Y'all ready? If u is equal to x squared plus 1, and I replace x with the b, that's going to give me u is equal to b squared plus 1, and then replace it with the a, u is a squared plus 1. And the only one that satisfies that with half in front of the integral is what? C.